We discussed earlier sign and magnitude as one way that we can do sign numbers. And now we're going to look at a second way, which is called 1's complement. Now, 1's complement is unique, and this is going to change the way we view numbers. It's a little bit of a different form than what we're used to when we talk about decimal numbers. So how do we start off? Well, we start off with, we still have the idea of a magnitude. And let's just say I want to cover magnitudes of 0 to 7. Well, 0 to 7 means that requires 3 bits. And then we're going to add 1 extra bit that's going to form up the sign. But this sign is a little bit different than the sign of sign magnitude. The first bit, the one on the left-handmost sides, will always be able to tell you the sign. We're still going to use the same format. A 0 leads to being a positive number. A 1 leads to being a negative number. But there is going to be a difference. The difference is that it's the complete set of four binary digits that lead to the overall number. All right, so let's look at positive numbers, and then we'll try to figure out the way unsigned numbers are going to work. Okay, so here I'm going to do 4 digits. What I'm really concerned about is just the magnitude. And the magnitude we said was going to cover from 0 all the way to 7. Now, with this setup, we're going to have a mirrored effect. Where you see I have a positive 0, I will produce a negative 0. I have a positive 7, I'm going to produce a negative 7. Well, how do we go about doing that? Well, the way 1's complement is done, we're going to start off with some number. For example, let's say we're starting off with all zeros. We know this is positive 0. And the way we're going to do 1's complement is we're going to take one of these bits at a time. And when we take one of these bits, we're going to take it and we're going to not it. We're going to take the complement or the negation of it. So a 0 becomes a 1. Next item, this next 0, we not it. It's going to become a 1. The next bit is this 0. We're going to not it. It's going to become a 1. The next bit is a 0. We're going to not it. We're going to get a 1. So we see we have 1, 1, 1. So that's the way we're going to do 1's complement. Okay, so a positive 0, we do 1's complement. We change every bit. We get all 1s. All right, now let's take, for example, positive 1. Positive 1 is 0, 0, 0, 1. So we're going to start with the least significant bit. Least significant bit is a 1. What's the opposite of that? Is a 0. What's the opposite of a 0? 1. Of a 0, 1. Opposite, 1. So we see that's how we get to the value of negative 1. Next item, I'm doing positive 2. I'm going to do the same thing. Starting with the rightmost bit, a 0 becomes a 1. A 1 becomes a 0. A 0 becomes a 1. A 0 becomes a 1. Let's do the next one, a positive 3. Starting with the right bit. 1 is a 0. 1's a 0. 0's a 1. 0's a 1. Okay, let's continue doing that. For 4, 0 becomes a 1. 0 becomes a 1. 1 becomes a 0. 0 becomes a 1. For 5, it's 0, 1, 0, 1. 6, 1, 0, 0, 1. 7, 0, 0, 0, 1. So you can see that, yes, that first bit on the left tells the sign, but the remaining bits are different than sign magnitude. 0, 0, 0, that's not the magnitude of 7. So everything has a little bit different notation to it. Now, you might say, why would somebody want to use numbers in this method? And again, it's to try to get that we can do a more straightforward mathematical operations. So when we're talking about mathematical operations, again, talk about sign magnitude. We said, okay, if I wanted to do plus 5, positive 5 plus a negative 6, what did we do? We thought it on our mind, taking 6 and subtracting 5, which would produce the value of 1. But let's change that instead of us trying to do math in our head to try to figure out what operation I need to do, let's just take the numbers we have and work off of them directly. So here, doing 1's complement, I want to do a positive 5 plus a negative 6. Well, positive 5 leads to 0, 1, 0, 1. And then a negative 6 leads to 1, 0, 0, 1. Now, what operation did I want to do? I wanted to do an addition operation. So that's what I'm going to do. I'm going to add these numbers together. So starting here at the right side, what's 1 plus 1? 1 plus 1 is the value 2. So I get a carry of 1. Next, what's 1 plus 0 plus 0? Well, that's number 1. Okay, so I'm going to write that down. Next, what is 1 plus 0? All right, that's a 1. And then last, what's 0 plus 1? That's a 1. Okay, so I have this answer here. And this answer, all I can tell is we have a negative number. How do I know I have a negative number? Because the most significant bit is a 1, and that's telling us a little bit about the sign. Well, what number is this? Now, I wanted the result to be a negative 1. So let's take this item right here, and I have 1, 1, 1, 0, and I know this is a negative number, and let's try to figure out what it is. So let's take this and convert it into a positive number. Let's do 1's complement on it. Okay, if we're going to do 1's complement, a 0 becomes a 1 becomes a 0, a 1 becomes a 0, and a 1 becomes a 0. This is positive 1. Well, what I'm really concerned about is what's the magnitude. Here it's a 1, so I know the magnitude is a 1, and because of this bit telling me the sign, I know this turned out to be negative 1. Well, look at that. I didn't have to do any type of rearranging. I just needed to know, take the number, turn it into a sign, 1's complement binary, add them, I get the right result. There's no reorganizing. Okay, but there is going to be a little bit of a catch. Let's look at the example here. The example I want to do is negative 2 plus negative 1. Okay, what should this answer be? Okay, that should be a negative 3. So let's do this operation here. Okay, 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1 is 2. And then 1 plus 1 plus 1 is 3. All right, I had 4 bits to start off with. My answer needs to be 4 bits. So let's look at this. We have 4 bits, 4 bits. We need the result to also be 4 bits. Now in here, if we just take this number as itself and forget about the carry, I get 1, 0, 1, 1. Let's figure out what number this is. So let's do 1's complement, 0, 0, 1, 0. And this is, if we look at the weights, the first weight says 1, 2, 4. This is a 4. So this is telling us we have negative 4. Well, negative 4, that's not the correct result. The correct result we wanted was a negative 3. Well, we can easily fix this. How do we fix this? Well, it ends up being that this carry becomes important. And what we're going to do is we're going to take the carry and we're going to add it back into our answer. So let's add in this 1 bit here. What's 1 plus 1? That's 2. 2, 1, 1. And this here, that ends up being a negative 3. So if I get 1, 1, 0, 0, I do 1's complement to it. I get 1, 1, 0, 0. Well, that's the number 3. And then the most significant bit being a 1. Well, what was that item in green called? We have a name for it. We call it the end around carry. We always take what the last carry was and we ended up adding it back in. So let's do another example. Let's do negative 5 plus 6. What do I want the result to be? I want the result to be 1. So what's 0 plus 0? 0. What's 1 plus 1? 2. What's 1 plus 1? 2. What's 1 plus 1? 2. here we can really see that the bottom 4 bits are 0. That's not our answer. I want to take this 1 and add it in. So I'm going to do that. I get 1, 0, 0, 0. Well, guess what? That ends up being a positive 1. So we can see that just by taking that carry and adding it in, we're always going to get our result. Now, one thing that I did skip, I'm going to come right back to, is that when we do a signed number has a range. The range now is a little bit different. For n bits, we say it's from -2 to the n minus 1 all the way up to 2 to the n minus 1 minus 1. Okay, so let's come back to this. And let's say we wanted to do 4 bits. And with 4 bits, that's going to give me a range of -7 to 7. That are the only numbers that I am able to represent. But let's say I wanted to do 5 plus 5. Well, we know the answer is going to be 10, and that answer is above our range because we see that 10 is not in our range. Well, this is going to have a name for us. What we call this is we call it overflow. And what overflow means is we can do our math operation, but we're going to end up with the wrong result because we're not able to store that number 10. So let's just add this. We add it. What's 1 plus 1? That's 2. That's a 1. That's 2. There's a carry of a 0. We add it back in, but that doesn't change any of our results. Well, 1, 0, 1, 0, that was our answer, but that's not positive 10. What number is it? Well, let's do 1's complement to it. 1's complement is 1, 0, 1, 0. This is telling us that we have 5 with the sign telling us I have a -5. Well, -5 was not the result. This is, again, an overflow. An easy way you can tell if you have overflow is if you add 2 positive numbers together, you have the potential of having overflow. You have the potential going above positive 7. You will know you have overflow because you will get a negative result. So look at here. We have a positive, our answer is a negative. That's going to be overflow. The same thing will happen is if you add 2 negative numbers together, you have the ability to be above -7. You could be -8, -9, -10. Well, all of those, you would see you have negative numbers. Your result is a positive number. That would be overflow. If you're doing any operation of a positive number and a negative number, you'll never have overflow. You'll always stay within that range. All right, so that's how we do 1's complement. We're not done with ways of representing signed numbers. We have one final method.